Hello, I'm Naveen Sanjula from Department of Mechanical Engineering, University of Srilanka. And this is the introduction video of my final year research project on introducing novel 3 degree of freedom joint mechanism for modular type underwater snake robots.
Almost all the snakes has the ability to swim, but some of them has the special adaptations to swim and live underwater. And sea snakes are few of them. And these are amazing creatures who can maneuver through their gait patterns, and they have built bodies with fins and also elongated cross sections and slenderness to live under the sea environment. Underwater snake robots are mainly used for few reasons. They have an excellent maneuverability because of their slender bodies, and also with their higher number of degree of freedom, they can easily in tight spaces. Also, when it comes to highly developed versions of underwater snakes, they can perform underwater manipulations, and also they have the capability of maneuvering with or without thrusters. So when they maneuver without thrusters, their disturbance to the nature is very much lower. And also by making these sort of snake robots, it is possible to research on actual sea snakes.
That is the basic introduction into underwater snakes and underwater snake robots. So what is I'm doing here in my research? Basically, the number of researchers on this field is low. So there are a lot of opportunities to build up. So I found this sort of an opportunity. That is, there's no joint mechanism existing with yaw, pitch and twist motions. And I'm going to introduce novel joint mechanism with those 3 motions.
In order to start the project, I was searching through the literature to find a proper joint mechanism details, and I found quite a few and even made a comparison between them. The best way is to do that is by the available degrees of freedom at the joint module. So most of the robots currently in existence have 2 degrees of freedom, while few of them has 1 degree of freedom, and there's only one robot that consists with 3 degrees of freedom. And even that, it doesn't have twisting motion capability. It has pitch, yaw and stretch motion capability. Initially, I was able to come up with few conceptual designs. Basically, these are based on the existing literature on underwater snake robots. Based on the conceptual designs and the requirement of the joint module, I was able to design 2 different joint mechanisms, which consist of twist, yaw and pitch motion. So I have selected the joint module 2 based on few reasons. It has the advantages of simplicity and easy to water seal compared to the joint module 1. However, this has the disadvantage of radial load, which is acting on the twisting motion controlling motor directly. That has to be tested and verified practically. This is the prototype 2 joint that has been designed with consisting of the 3 degree of freedom at the joint module.
So that is the progress so far and how I introduced a novel joint mechanism for modular type underwater snake robots. So if you're wondering what's up next, you can stay tuned for our project introduction video. Thank you.